I am going to teach you about the concept of Kirchhoff's rule. Kirchhoff's rule. So I repeat. So we spell it as Kirchhoff's rule. Okay. So this is entirely based on the concept that we read before. So the backbone of this is Ohm's law, the electrical circuits that we came across, the voltage, the current concept, the resistors, and so on. So first I will start with the electrical network. So what is an electrical network? Electrical network. And I am sure that most of you are very familiar with the electrical network. So it is a combination of electrical components. It means a resistors, voltage source or a current source. It's a combination of resistors either in series or in parallel, and we have a source for the current or the voltage. Clear? So among all of this, we are connecting as an electrical network. So that combination, we have an electrical network. In this electrical network, the current will be flowing through the resistors. When a voltage is applied to a network, the current will be flowing through the entire network. In our real life, I repeat here, நம்ம electrical networkல என்னன்னு சொல்றோம்? நம்மளுக்கு ஒரு resistors தான் combination of series line connect பண்ணிருக்கலாம் இல்ல parallel line connect பண்ணிருக்கலாம். Series connection என்னன்னு முன்னாடியே பார்த்தோம். Okay. So series connection என்ன? Resistor R1 and this is R2. This is a series connection. Parallel means this is resistor R1 and R2. Parallel connection, this one is a series connection. Clear? So இந்த மாதிரி ஒரு electrical networkல series combination resistors இருக்கும். இதுக்கு நம்ம voltage apply பண்ணுவோம். So if you apply voltage, the current will be flowing. This is the voltage and here is the current. So for this, the current comes to here and splits here and again it combines here. Okay. So very best example is our home. We take our home as a very best example for an electrical network. So வீட்டு எடுத்துக்கிட்டீங்கனால நம்ம வீட்டுக்கு மெயின்ல இருந்து என்ன பண்றோம்? Supply எடுத்துக்கிறோம். We are taking the supply from the main. Okay, electrical main. From there, the voltage is being supplied to all the domestic appliances. வீட்ல இருக்க எல்லா appliancesக்கும் நம்ம என்ன பண்றோம்? We are giving the supply, and through that supply we are taking the current and distributing to the loads. And what is a load? இங்க load னா என்ன? Electrical load. The load, electrical load அப்படினால எல்லாமே இங்க எப்படி மாத்திக்கணும்னா resistor. Okay, everything should be considered as a resistor, and this is applicable only for the DC circuits. Please be clear. அது என்னங்கிறது நீங்க AC circuit படிக்கும்போது கிளியரா புரியும். இப்போதைக்கு we restrict our study to the word resistor. Okay, it means we have to consider each and every load. Load means a fan, a tube light, a TV, a washing machine, a motor, a generator, or your cell phone, an adapter, anything that consumes electricity, we call it as a load. Are you clear, students? So எல்லாத்தையும் நீங்க சர்க்யூட்டா வரையும்போது நான் ஒவ்வொரு இடத்துலயும் நான் ஒரு ஃபேன் வரைய முடியாது. You cannot draw the image of the component, a fan diagram, a refrigerator diagram, okay, a tube light, a motor, இது எல்லாத்தையும் இமேஜா நீங்க டிரா பண்ண முடியாது. How to represent that? எல்லாத்தையும் எப்படி ஒரு சர்க்யூட்ல வரைவீங்க? That means everything consumes the current. The current is transferred or taken by the component through any wire. அதுல இருக்கிற wire தான் என்ன பண்ணும்? அந்த current consume பண்ணிக்கும். Okay? So எல்லா conductorsமே, that we call it as a conductor. எல்லா electrical componentsலயுமே conductors இருக்கும். அந்த conductorக்கு என்ன இருக்கும்? resistance value irukku. Okay, no component has a zero resistance. So that resistance value will be intimated in the electrical network. Clear? The resistance value of each and every load is enough to intimate the load. ஒரு load நீங்க சர்க்யூட்ல ரெப்ரசன்ட் பண்றதுக்கு அதோட ரெசிஸ்டன்ஸ் வேல்யூ இருந்தா போதும். அதோட இமேஜ் அது என்ன பேர் எதுவுமே தேவையில்லை. It is not necessary to represent that either it is a fridge or a fan or a bulb or anything. Okay, it's enough if we represent it as a resistance value. அப்போ ஒரு electrical network வரையறதுக்கு நம்மளுக்கு என்ன வேணும்? We need the voltage source and the components and the resistance value of each component. The general term used as is a load. Okay, right. Now we move on to this. Why we discuss this Kirchhoff rule is, in an electrical network we have many loads connected. In many loads different currents are flowing. நிறைய current flow ஆகும். ஒவ்வொரு லோடுக்கு தகுந்த மாதிரி current அதை எடுத்துக்கும். Each and every load will consume the current depending upon its resistance value. So somewhere we have to find the current. ஒரு நெட்வொர்க்ல எல்லா இடத்துலயும் நமக்கு கரண்ட் தெரியாது. சில இடத்துல கரண்ட் அதிகமா இருக்கலாம், சில இடத்துல கரண்ட் கம்மியா இருக்கலாம். அப்ப எனக்கு கரண்ட் தெரியாது, இல்ல எனக்கு கரண்ட் வேல்யூ தெரியலனா how do I find the value of current in an electrical network? இல்ல எனக்கு வோல்டேஜ் தெரியாது, இல்ல ரெசிஸ்டன்ஸ் தெரியாது. Any of the unknown parameters can be found out by using this Kirchhoff's rule. Now I will jump into the Kirchhoff's rule. So what is the Kirchhoff's rule? So a Kirchhoff's rule is the first rule I will read as the statement given in your book. Okay, for your convenience I will read as the same statement that is in your book. So please listen carefully. It will be very convenient for you if you have the book with you always. And you can make a note of the important points what I say. A junction rule. Go to the page number 116 and you make a note of the point. Junction rule. First one is a junction rule. At any junction, the sum of the currents entering the junction is equal to the sum of the currents leaving a junction. So now I will draw an electrical network as given in your book. Okay. So let us consider the network given. So we have a resistor and another resistor we have. Then negative or positive. Again we have a positive and a negative. Okay. This is a, let us consider a electrical network. So we have resistors. These two are in series and these two are in series, and this resistor is in parallel with these junctions. Okay. I will name as if given in your book I2. The current is I1, and here this is I2, and here is, what is this? This is the G, point G. This is 80 volts. This is G. That is, the G represents the generator value. Okay. That is F. And this is 1 ohm. And here is the current I2. And here the point. This is 30 ohm. So somewhere this is I3 amp. Yeah, this is I3. And the direction of the current is north. So students, you consider I have drawn the circuit as if given in your book, and you see we have a voltage source. Two voltage sources are there, 80 volt and 45 volt are there, and the resistors, this 2, 3, 4, 5 resistors are there. I have named the points. The points are being named here: A, B, C, D, E, F, G, H. So why these points are named? It means that somewhere there is a meeting of the components. Okay, it may be a source or a load. Okay, the junction, the meeting of the electrical components or the load. We name it as a junction. At that junction, the components are meeting, right? The direction here it is given as in this direction. Here the direction is given as in this direction. Yeah. Or the same way. Listen carefully, students. The main thing I want to tell you is, you consider a resistor. When you consider a resistor separately, this is a very main thing you should keep in mind while you are working with these rules. Okay? A very simple rule, very simple rule. Provided you should be very cautious in giving the polarity to the values. Polarity na enna sollirken. நீங்க ஒரு கரண்ட்டுக்கோ வோல்டேஜ்க்கோ என்ன சைன் கொடுக்குறீங்கிறது ரொம்ப இம்பார்ட்டன்ட். சரியா? என்னன்னு சொல்லுங்க. ஒரு ரெசிஸ்டர் இருக்கு, அந்த ரெசிஸ்டர்ல கரண்ட் ஃப்ளோ ஆகுது. கரண்ட் ஃப்ளோ ஆகும்போது ஃபர்ஸ்ட் ஒரு பாயிண்ட்ல என்டர் ஆகுது, இன்னொரு பாயிண்ட்ல it is leaving at one point. It is entering at one point and it is leaving at one point. அப்ப அது என்ன கன்சிடர் பண்ணனும்னா, how do we consider the polarity is, if the current I is leaving, current enter ஆகிற பாயிண்ட் எப்படி எடுத்துக்கணும்னா பாசிட்டிவ்னு எடுத்துக்கணும். கரண்ட் முடியிற இடத்தை எப்படி எடுத்துக்கணும், வெளியில போகிற இடத்தை நெகட்டிவ்னு எடுத்துக்கணும். கிளியர்? நீங்க ஒவ்வொரு ரெசிஸ்டருக்கும் ஸ்டாண்டர்டாகவே கரண்டோட டைரக்ஷன் போட்டீங்கன்னா, ஒரு டயக்ராம்ல நீங்களே you can give your random values, directions you can yourself specify. ஓகே, உங்களுக்கு நெட்வொர்க்ல क्वेश्चनல இப்படி தான் இருக்குன்னு கொடுத்திருந்தா நீங்க அதே ஃபாலோ பண்ணி ஆன்சர் கண்டுபிடிக்கணும். if not, you can yourself, if no current directions are given, you are just asked to find the directions of the current or the current values. You can randomly choose the current direction, and what you have to consider is the current entering a resistor. That point should be considered as a positive, and the leaving point you consider as a negative. That is the main logic. This is very important, students. So everyone should keep this in mind. Yeah, இது உங்களுக்கு அத மென்ஷன் ஆயிருக்காது. This is not mentioned in your book, but you should keep this in mind. அது டைரக்டா உங்களுக்கு எக்ஸ்பிரஷன்ல தான் இருக்கு. This concept is directly given in an expression. Okay. So now what we have to find is, here we have to find the values of current I1. What are the currents we have? So we have the current in the voltage source la irundhu current எனக்கு வெளியில வருது. அதோட கரண்டோட வேல்யூ என்ன கொடுத்திருக்காங்க? I3 கொடுத்திருக்காங்க. The value of the current given from this 45 is, since these two resistors are in series, the current flowing through these two is same. Clear? So this current I3 ஒரு ஜங்ஷன்ல வந்தனே நமக்கு current split ஆகுது. Okay, the current is getting divided, I1 and I2. Everything is given directly. Okay, so ரெண்டு divided. Next one is, இங்க என்ன கொடுத்திருக்காங்க? கரண்டோட direction I already mentioned. சரியா? current directions பார்த்து கன்ஃபியூஸ் ஆகாதீங்க. வெரி இம்பார்ட்டன்ட் that உங்களுக்கு இப்படினாலே என்னங்க இந்த எந்த டெர்மினல்ல இருந்து வெளியில போகுதுன்னு பாருங்க. ஓகே, இந்த ஏரோவை இங்க கொடுத்தாலும் ஒண்ணுதான், இங்க கொடுத்தாலும் ஒண்ணுதான். ஓகே, this arrow might be specified anywhere in this path. அதனால ஒரு டெர்மினல் எடுத்துக்கங்க. அந்த இந்த நெட்வொர்க்ல எனக்கு ஒரு வோல்டேஜ் சோர்ஸ் இருக்கா, வோல்டேஜ் சோர்ஸ்ல இருந்து வெளியில வருதான்னு பாருங்க. ஓகே, வோல்டேஜ் சோர்ஸ் நோக்கி போகுதா இல்ல வோல்டேஜ் சோர்ஸ்ல இருந்து வெளியில வருதா? You think, you see whether the diagram given is the current is going out from the voltage source or going towards the coming towards the voltage source. So you can consider it means it is either clockwise or anti-clockwise. Only two options we have, either clockwise direction or anti-clockwise direction. Okay, so இதுக்கு மீனிங் என்னன்னா ப்ராப்பரான மீனிங் என்ன டிரா பண்ணிடுங்க. கரண்ட் இப்படி இங்க ஸ்டார்ட் ஆகி இப்படியே போயிட்டு இப்படி ஃபுல்லாவே வருது. The direction of the current for this is the current is going here, going here, going here, going here, and it is ending here. This is the meaning for this simple diagram. Okay. And now, so what did I told you? This. So the sum of the current here is equal to the sum of the currents leaving. So I3 equals to I1 plus I2. Then here what it is given in this loop. Okay, this network is divided into two networks. This one loop and this is one loop. Okay, ரெண்டா ஸ்ப்ளிட் பண்ணிருக்காங்க. இங்க பாத்தீங்கன்னா கரண்ட் I2 வந்து இங்க போகுது. I2 இங்க போனோனே என்ன ஆகுது? What is the current coming here? The same I1. இங்க வர I1 தான் இதே ரெசிஸ்டர்ல டிராவல் ஆகி the same I1 is coming until here and it is meeting at this junction. Okay, and I1 and I2 here also I2 is coming and at this point I1 is entering, I2 is entering, and the same I3 is, you got the I3. Okay, so now you are clear with the current, how the currents are splitting and getting added. Now we have to write the equations based on the Kirchhoff's rule. First rule I told you. So in this network, as per the first rule, at any junction, the sum of the currents entering the junction is equal to the sum of the currents leaving the junction. So what is the current here? At this current I3 equals to, what is the current leaving this junction A? I1 plus I2. Clear? Again you take the junction D. You have only two junctions here. In the point in the junction I எடுக்க முடியாது. ஏனா அப்படியே ஸ்ட்ரைட்டா தான் போயிடுது. Okay, what is entering is what is leaving. I1 equal to I1. Okay, I1 equal to I1. So here you take the junction D at A junction. This is for junction A. Junction at junction D, what are the currents entering? I1 is entering and I2 is entering. The current leaving is, so the arrow mark என்ன denote பண்ணுது? இப்படி வர current என்னது? I3. This I3 is applicable for this. Okay, so here I3 equals to I1 plus I2, the same. In the junction என்ன என்றாகுது? I1 என்றாகுது, I2 என்றாகுது. So both are getting added. So this is the current law. Okay, junction rule. This we call it as a junction rule. The next one is, so this proof, when the currents are studying, there is no accumulation of charges. So nowhere the current gets accumulated. It is a continuous. The process is continuous. Okay. The next rule is loop rule. So sometimes the concept may not reach you immediately. When you work out on a problem, immediately you can grasp the concept. Problem work பண்ணும்போது உங்களுக்கு immediately அந்த concept புரியும். Circuit நாலே no need to get frustrated or fear. Okay, it's very simple of working out in circuits. நான் எல்லாமே டீல் பண்றது என்னது ரெசிஸ்டரையும் வோல்டேஜ் வச்சு தான் டீல் பண்ணவே போறீங்க. ஓம்ஸ் லா இத மூணு நல்லா தெரிஞ்சா போதும். You should be very careful clear with Ohm's law. Ohm's law தான் எல்லாமே உங்களுக்கு டாமினேட் பண்ணுது. Then loop rule. Loop rule ல என்ன சொல்றீங்க? I will tell you what is the loop rule given. The algebraic sum of changes in potential. The algebraic sum of changes in potential around any closed loop involving resistors and cells in the loop is 0. So I repeat, the algebraic sum of changes in potential around any closed loop involving, that is closed loop, you have a closed loop involving resistors and cells involving. So this is a closed loop. Okay, so open loop na enna closed loop na enna solreenga எனக்கு இங்க switch இருக்கு. So this is an open loop, the current is not flowing. Closed loop na enna or switch போட்டா அது it is a closed loop. Okay, so the algebraic sum of changes in potential around any closed loop involving resistors and cells in the loop is 0. That means what are the potential? Potential there is a drop in each resistor. What is the potential across the resistor now? What is the potential across this? That is V across each resistors. Previously we have studied Ohm's law. If this is the voltage, this is the thing we studied previously. That is V is R1 and R2. So that is the voltage is V and the current flowing is I. So what is this voltage is dropped in R1 and R2. Okay, now apply பண்ற voltage எங்க போய் drop ஆகுது? ரெண்டு ரெசிஸ்டர் எலிமே ஷேர் ஆயிடுது. Okay, so the applied voltage is dropped in R1 and R2. What is the voltage drop? That is what is the potential across R1 and R2? That is the current is IR1 equal to V1, IR2 equal to V2. Okay, so this you call it as a potential across that resistor. So over a resistor across the potential enna keta and the potential node value, okay, that is equal to current times the resistance value. Current times the resistance value. Ohm's law da concept. So V1 equal to IR1. So we can make a note of this diagram. So this is the potential. Potential drop ne solla. So on the resistor la potential drop enna keta IR1. Endha or resistor edutrom and the resistor la what is the potential drop na resistance value times the current flowing through that resistor. Okay, you can pause the video and make a note of this. This is very important and this is also very important. That is entering in and this is leaving in. This is the actual strategy. Okay, நீங்க current இப்படி கொடுத்திருக்கீங்க, entering in positive, leaving in negative. உங்களுக்கு டயகிராம்ல ஆப்போசிட்டா லூப் கொடுத்திருந்தா நீங்க அப்படியே என்ன பண்ணீங்கன்னா So at junction A, the current is leaving here. So how to find the current here? So you got this. This loop rule pota enna varum. So now this is the junction rule for junction A and junction D. When I apply a loop rule, so we have two loops. So loop 1 and loop 2. Now I am going to write the equation for the loop rule. Equation using loop rule. So let us consider this first one as a, this is the first loop, loop 1. Loop 1. This is loop 2. Let us check what is the thing. So loop 1 and loop 2. For loop 1, what they have told as per the law, the algebraic sum of changes in potential around any closed loop involving resistors and cells in the loop is 0. So நீங்க என்ன பண்ணா அப்ப அந்த லூப்ல இருக்கிற எல்லா பொட்டன்ஷியலையுமே இன்டெக்ட் பண்ணி 0 பண்ணிடணும். அப்ப how do you start? Where do you start? So where do you start? If you have a cell in that loop, you can start from there. That is a simple idea. ஏன்னா ஒரு செல்லில் இருந்தால் உங்களுக்கு கரண்ட் போகும். இங்கே கொடுத்துருக்கிறது நிறைய கரண்டோட டைரக்ஷன் தான் கொடுத்துருக்காங்க. The direction given here is the direction of the current. Okay, the direction of the loop actually. So it's very better to start the direction from the equation from the cell if given. So here you have the cell here. Now, what is the value of this? This is 45. So 45 is the value. Clear? So 45. So you have to add the cell in the cell value apply put. That positive or negative or empty in So because the loop is like this. Negative and positive the pole. Loop diagram another. I will draw the loop diagram separately and it will be very comfortable for you. So you consider this loop. This is the first loop, you think. It means the current is flowing. This is the path of the current. Okay, clockwise flow. Okay, clockwise neenga loop la current flow ஆற மாதிரி கொடுத்திருக்காங்க. The direction is given. It means the current flows from negative to positive. Negative la irundhu positive vanda எனக்கு என்ன ஆகுது? There is a increase in potential. Positive to negative means there is a decrease in potential. That is the concept. ஒரு சைன் ஒரு நம்பருக்கு முன்னாடி சைன் எப்படி போகணும்னா நெகட்டிவ்ல இருந்து பாசிட்டிவ் வர மாதிரி இருந்துச்சுன்னா உங்களுக்கு டயகிராம்ல கொடுத்திருக்கிற லூப் சிம்பலுக்கும் உங்களோட செல்லுல இருக்கிற பொட்டன்ஷியலும் இன்க்ரீஸா டிக்ரீஸாங்கிறது மேட்ச் ஆச்சுன்னா அதை பொறுத்தே சொல்லிடலாம். இப்போ உங்களோட லூப் கரண்ட் இந்த டைரக்ஷன் வருது. The loop current is coming in the clockwise direction. So you have to check from here. So this is negative, this is positive. So the loop current is actually this is from negative to positive. So negative to positive and the value is increasing. Okay. So it means that is plus 45 only. Okay. Now what is the current given here? I3. So we get the current another. This is I3 is flowing here. And again here, what is the current flowing? This is I1. Because in this loop, I3 is divided here. I2 is going only, I1 is flowing here. Clear? So the name of the junction is A. So in this, what is the loop here? When you So since both are in series, you can add the resistors. Loop என்ன பண்ணுங்க, எவ்வளவு simplified வரைய முடியுமோ அவ்வளவு simplified வரையுங்க. நீங்க இந்த ரெண்டையும் சேர்த்து இதை ஆட் பண்ண கூடாது. You should not add these three. Why? Because at this junction the same current is not flowing. Same current flow ஆனா மட்டும் தான் அது சீரிஸ்ல இருக்குன்னு அர்த்தம். இல்லாட்டி அது சீரிஸ் கிடையாது. ஏன்னா இங்க பார்த்தாலே தெரியும் I3 இது வரைக்கும் தான் வருது. இதுக்கு அப்புறம் என்ன ஆகுது, I2 இந்த செகண்ட் லூப் போயிடுது, I1 மட்டும் தான் மேல வருது. அப்ப இந்த மூணு ரெசிஸ்டருமே என்ன ஆகாது, சீரிஸ்ல இல்லை. So only different currents are here. Clear? So you should not write this I1 as I3. Don't do that mistake. So you just apply the rule. Of a current over direction அப்படினா this entering is, it is very better to mark as positive negative positive negative. Okay? So உங்களுக்கு கொடுத்திருக்க current over direction என்ன, இந்த டைரக்ஷன்ல தான் current வந்திருக்கு. current over direction பாருங்க, loop direction பாருங்க. அப்போ உங்களுக்கு கிளியரா புரியும். உங்களுக்கு டயகிராம்ல கொடுத்திருக்க current over direction இப்படி தான். ஓகே? அப்ப entering in positive, leaving it is negative. Again entering in is positive, leaving it is negative. Entering in is positive, the current I3 is entering. Entering is positive, leaving it is negative. Okay. Here the current I1 is going here. Okay? Wait. So just leave this for you and will make it confusing. So now you just see the current direction and you make positive negative signs to the resistors. Then you take this I1. I1 இப்படி போகுதா, அப்ப current enter ஆகுறது positive, leaving it is negative. ஒரு ரெசிஸ்டருக்கு முன்னாடி பின்னாடி என்ன பண்ணுங்க, polarity வரைஞ்சுங்க. அப்போ உங்களுக்கு ரொம்ப கன்வீனியன்ட்டா இருக்கும். So current flow பொறுத்து என்ன பண்ணுவீங்க, ஒரு ரெசிஸ்டருக்கு முன்னாடி பின்னாடியும் சைன் போடுங்க. Then after doing this, what you do is you now consider the loop. You now consider the loop. Okay? How does the loop? What is the direction of the loop given? First current போட்டுட்டு அதுக்கு சைன் போடுங்க. எதுக்கு பண்ணோம்? First you draw the current given. Give the direction of the current as given in the question. Then what you do is, based on the current, you put the polarity for each and every resistor. Second thing, then you take the loop direction given. Okay? இப்போ கொடுத்திருக்க loop direction இப்படி தான் கொடுத்திருக்காங்க. Okay. So it means the loop direction here is positive to negative. Loop direction படி நான் போன என்னது, positive to negative. It means நல்ல கவனிச்சுக்கங்க, loop direction படி நான் செல் மட்டும் எடுங்க. If you take this cell, when you take the direction of the loop, you take the cell and you check either it is coming from negative to positive or positive to negative. अब cell பாத்தீங்கன்னா negative ல இருந்து positive வருது. negative ல இருந்து positive வந்துச்சுன்னா என்னது, there is a increase in potential. அப்ப அதனால தான் இந்த plus 45 போடணும். ஓகே? அப்ப இந்த ரெசிஸ்டர்ல பாருங்க, this is what is this resistor, this is 1 ohm. Okay? Here it is 40 ohms. Here it is 40 ohms. So what is the here voltage? Positive to negative. Positive ல இருந்து negative வந்தாலே என்ன அர்த்தம், there is a drop. For positive ல இருந்து positive is higher potential, negative is the lower potential. So when the value comes from positive to negative, there is a drop. So you have to put negative. So what is the current there? I3 is the current flowing. I3 times what is the potential? Potential means current into resistance. What is the resistance? That is 1 ohm. I into R. Again you go for the next resistor. What is this resistor? That is I3. That is either it is positive to negative. Yes. The current already I have mentioned the sign. Okay, based on the sign. Now this loop is going from positive to negative. Okay, so minus positive to negative means what is it? There is a drop. That is the same current I3 times 40. Then again I will continue the loop until I reach here. In the cell வர வரைக்கும் நான் என்ன பண்றேன், லூப்பை க்ளோஸ் பண்ணனும். லூப்ல இருக்கிற எல்லா drops-ஐயும் நான் என்ன பண்றேன், ஆட் பண்ணிட்டே வரேன். I am adding all the drops because it is an algebraic sum. It means I am adding all the drop. எங்கெல்லாம் drop ஆகுது அந்த voltage. Okay, அப்ப இங்க பாருங்க. So here also there is a drop here. What is the drop? The loop என்னது இப்படி தானே வருது. So here there is a positive to negative. Positive to negative means again it is negative sign. There is a drop here. So it is minus I1, which is equal to I1 into what is the resistance value here? The resistance value is 30. So resistance value is 30. So I1 into 30. So after this, do we have any other resistors or voltage or cell? No. இப்போ இந்த லூப்ல இருக்க எல்லாத்தையும் கவர் பண்ணியாச்சு. So it is equal to 0. As per the rule, this is equal to 0. Clear? So அப்ப light terms எல்லாத்தையும் ஆட் பண்ணிருங்க. Light terms என்ன? ஒரே currents. I3 ரெண்டு ஆட் பண்ணிருங்க. I3 into 1 that is 45 minus I3 na minus 41 I3 minus 30 I1 which is equal to 0. So this is the first loop. So please pause the video and make a note of it. Video pause பண்ணிட்டு diagram individually draw பண்ணுங்க. ஒரு loop எடுத்து தனியா draw பண்ணிட்டு அது bookல இருக்கிற சம் தான், but what you do is you take this separate loop and write this equation. ஒரு loopல equation error இல்லாம ரைட் பண்ணாதான் உங்களால பெர்ஃபெக்ட்டா ஆன்சர் அச்சீவ் பண்ண முடியும். Clear? It is very very simple. Unless if you draw the polarity மிஸ் பண்ணீங்கன்னா உங்களுக்கு சைன் மாறிடும். அதுக்கு தான் உங்களுக்கு அந்த பாசிட்டிவ் நெகட்டிவை நான் இன்டிமேட் பண்ண சொல்லிருக்கேன். So students, pause the video and then you write this. Now let's move on to the second loop. Okay, so first loop we have completed and move on to the second loop. Yeah, I will erase it. So the same now you apply for the loop 2. This is the second loop. So I will draw the circuit. This one. So this loop you draw it entirely as given. So this is 20, 21. Okay. Here one resistor. Okay, this is second loop. Yeah. So what is the direction given for this loop? This loop is in this direction. The direction of this loop is anti-clockwise. So I will mark this resistor values 41 and 20, and here it is. What is the value of 45 volts and the 1 ohm? This is 80 volts. Okay, now students, you see clearly, as done before, we have to assign the sign for each and every resistor. Okay, polarity in front and behind the resistor. So for that you have to draw the current as given in the circuit. First நீங்க என்ன பண்ணணும், ஒவ்வொரு ரெசிஸ்டர் முன்னாடி சைன் போட்டீங்கனாலே உங்களுக்கு டயகிராம் போடும்போது லூப்போட வேல்யூஸ் ரைட் பண்ணும்போது கன்வீனியன்ட்டா இருக்கும். ஸோ அப்போ கொடுத்திருக்கிற மாதிரி என்ன கரண்ட் வேல்யூ பாருங்க. ஸோ I2 is coming from here. This is the junction A and I2 is here. So this is I2. Okay. Then 80 here F and the current I2 is flowing here 1 ohm. The same current again here, that is I2 here. So இங்க வர I2 தான் என்ன ஆகுது, அந்த லூப் ஃபுல்லாவே ஃப்ளோ ஆகுது. At here the current is flowing is I3. The current flowing is I3. At this junction D to A ல என்ன current flow ஆகுது, I3 flow ஆகுது. Okay, so the current is flowing from current ஓட டைரக்ஷன் என்ன கொடுத்திருக்காங்க, இப்படி கொடுத்திருக்காங்க. Clear? So entering end is positive, leaving end is negative. Again current is going here in this resistor. Current entering end is positive, leaving end is negative. Now here current is going in this direction, so the entering end is positive, leaving end is negative. Clear? Now we apply the loop rule for this. So what is the loop rule? Let us start from the voltage source. So 80 volts. In the direction la dhaan irukku. Appa negative to positive is what? There is an increase in potential. So plus 80. Now then here what is the potential drop here? Positive and the negative pole. Okay. So that means there is a drop here, that is I2 into 1. Negative of I2 into 1. Again in 20 ohms, what is the potential drop? That is negative of 20 I2 into 20. Further, here we have a voltage source. What is the voltage source? The direction is loop or direction in the direction of the. Okay, so that means the sign is from negative to positive. Cell la enna increase aayide, negative la irundhu positive direction la loop direction irukku. Appo cell la enna panum plus 45. Clear? Then for I3 in the branch la enna current flow agudhu, I3 is flowing. That is I3 is 1, that is 40 minus I3 into 1 minus I3 into 40. Okay, so this are the algebraic sum of all the voltage drops. All the voltage drop in this electrical circuit. This should be equal to 0. This should be made equal to the 0. So I will clear this, and this should be equal to, this entire value is equal to 0. So what is the value we get finally? So I2 link panniranga, I3 and I3. So I will write here. Please follow the lecture. It's very better for you to write this. நான் எழுதுற மாதிரியே எழுதிருக்கேன். புக்ல உங்களுக்கு டைரக்டா கொடுத்திருப்பாங்க. இந்த எக்ஸாம்பிள் தான். They have given the values directly. I am repeating it with the polarity. சரியா? So அப்ப 80 constants na add பண்ணீங்க. 80 plus 45. This I2 minus I2, that is minus 21 I2, and I3 is what? Negative of 41 I3 equals to 0. Okay. So what is minus 2 I1 21, I2 minus 41 I3 equal to 40 125. So that is 21 I2 plus 41 I3 equal to 125. So So we had two equations. Okay. So three variables should be on two equations. We cannot find the solution. So we have to find another equation. Okay. And the first equation. What is the expression we got it before in the first loop? The first loop what we got it is. The first loop what we got is minus 30 I1 minus 41 I3 equal to minus 45. So these are the two equations. So these two equations we got for the first one. Okay. So this is how you will draw a circuit and write the equations. So after converting the circuit into an equation, you will find the value of the individual currents using the mathematical formula. Clear? So this is just an example for how to frame the equation from the network. Next, I will show you with an example very clearly. The hints are very important, students. So the main thing is you should follow the sign in front of the or back of the resistor. Please do not forget to put a sign in front of the or back side of the resistor, provided the sign should be based on the direction of flow of current. சரியா? ஒரு ரெசிஸ்டர் எடுத்துக்கிட்டீங்கன்னா கரண்டோட டைரக்ஷன் எந்த பக்கம் இருக்குன்னு பார்த்துட்டு அந்த ரெசிஸ்டருக்கு முன்னாடி ஒரு சைன் போட்டுருங்க. ஓகே, அதுக்கப்புறம் இந்த லூப்போட டைரக்ஷன் பேஸ் பண்ணி அது பிளஸ்ஸா மைனஸான்னு பார்க்கலாம்.